Now we will discuss about correlation. So what is correlation? Correlation is the mathematical relationship between the variables. Okay, so let me just show you with this diagram. Okay, so let us say if you are analyzing a certain data and let's say, and you have created a scatter plot over here, and these are the two variables. This is, the x-axis, and this is the y-axis. So here one variable will come, and here the another one. So if you create a if you see the distribution of your data, and if that distribution of your data is in a line, let's say this is your data point, and then this is your data point, this one is your data point. So if it is approximately in a single line, then you call it as a linear correlation. Okay, and then now we will see about two types of correlation. One is positive linear correlation, and the second is negative linear correlation. Okay, so first we will talk about the positive linear correlation. So let me give you an example over here. Let's say you are working in a job, and this would be your years of experience. Okay, this would be your years of experience, and this would be your salary. Let's say this is your salary. Now what happens is, during your initial years, let's say in the first year, you received some amount of salary. Okay, you received some amount of salary, so I can mark it over here, the data point. Then as your experience in your job increased, your salary also increased. You can mark it over here. Again, the number of years of experience increased. Okay, your salary also increased. So similarly, this will keep on increasing. Your years of experience increases, the salary also increases. It means the variable, this variable on the x-axis, as the variable on the x-axis increases, the variable on the y-axis also increases. See over here, this one increases, this is also increases. This x-axis, the value on the x-axis is increased, the value on the y-axis is increased. Similarly, value on the x-axis increased, value on the y-axis is increased. So now if you draw a line, a straight line over here, this is a straight line, consider it as a straight line. So if you draw a straight line over here, let me just put this. Okay, let's say, yeah. So if you draw a straight line over here, you can say that this is a positive linear correlation. As I told you, if the points over here in the scatter plot are approximately in the straight line, we call it as a linear correlation. Now when the variable on the x-axis increases, the variable on the y-axis also increases. So hence we call it as a positive linear correlation. Okay, now let us take an example of a negative linear correlation. Similarly, I will draw again two axes, x-axis and y-axis. Okay, this one is x and this one is y. Now take another example wherein let's say you brought a car, and the value of the car. Okay, so you can term it as the years, and here you can write the amount, okay, or the price of the car, the price of the car. Now during the initial year, the price of the car was very high. Then in the second year, the price of the car what you brought will depreciate, right? Then in the subsequent years it will again depreciate. It will again depreciate. So which pattern you will see? In this case, you saw an increasing pattern, as in the value on the x-axis increased, so the value on the y-axis also increased. In this case, as the value of the x-axis increases, the value of the y-axis decreases. As the x increases, x decreases. Sorry, y decreases. Value on the x increases, the value on the y decreases. So you see a different pattern over here, which is this way, which is also in the approximately in the same line. So this pattern, you call it as a negative correlation. Okay. Now let's say if you are visualizing a data wherein this is your x and y axis, okay, and in your x, your y axis. Now in this case, let's say you receive some data, okay, in this format. So here if you see, if you visualize this distribution of the data points in the scatter plot, you see that you cannot find any relationship between these two variables. Okay, so you can term this as no correlation there. So there is no relation between these two variables. So you can call it as no correlation. Now let us talk about the different measures of location. So in our earlier sessions, we have already seen and talked about mean, median and mode. We have basically gone through the examples, how to calculate the mean, median and mode, and also have walked through the R programs. Okay, so now let us talk about percentile, decile and quartile. So let's say in a class, if 90 percentile denotes number 87, then it is implied that 90% of the students have got marks less than 87. So here 90 percentile is the ninth decile. Okay. So let us now take an example and try to understand what are quartiles. Okay, so let us say that this is a sample set of data what we have, and these are the you can say that the um, income of a certain profession. Okay, so these are some random data set what I have created for our current example. So this is the data set. So let us first find the median of this data set. Okay, from this data set. So we have already seen how to find the median. So let us apply that process and find the median in this case. So what we will do is eliminate this top value from here, the bottom value from here. So as you can see, the data is already in the sorted order. If you receive a data which is not in the sorted order, first thing what you need to do is to first sort the data in the ascending or in the descending order. In our case, we have sorted it in the ascending order. Okay, so here you can see I've eliminated the first and the last value. Again, eliminate this one and this value, again this one and this value, again eliminate this value and this one. So here if you see, you have two values 46920 and 47897. So the median will be in between these two numbers. Okay, in between these two numbers will be the median. Okay, so here we will let's say we'll write, okay, what I'll do is we'll just take the screenshot of this and okay, so I have taken the screenshot. Now it will be easier for me to explain. Okay, so this one in between these two lines, in between these two lines, this is your median. Okay, I know my diagram is not so good. I'm not so good in drawing. Okay, so this is the median, which is in between these two lines. Then what we need to do is we need to find the Q1, the quartiles, quartile 1 and quartile 3. So what is this median? This median is actually quartile 2. Okay, so this one is the median is the quartile 2. We need to find the quartile 1 and quartile 2. So what we'll do is, see here, if you can see, you have 33215 over here, 46920 over here, then 36244, then 46786, and then what is remaining is 38890. So this would be your quartile 1. Again, what you have now, 47897, 88654 over here, 55763, 78070. Then what is remaining? 56853. So this would be your quartile 3. Okay, this is your quartile 1. This is your quartile 2, which is in between these two numbers, which is again your median, and this is your quartile 3. Now, if you talk about the interquartile range, which is called as the IQR, which is equal to Q3 minus Q1. Okay, so here the Q3 is this one, 56853. I'm not going to write this, 56853 minus 38890. So that would be your interquartile range. Now let's say if you want to draw a box plot and if you want to visualize where you can find that. Okay, so how to find that? So let's say this is your box plot. Let me draw that. Again, I'm not so good in drawing, so please bear with me. Okay, this is just for your explanation. Okay, so this is your box plot. Now if you visualize this, this would be the minimum value, this one. Then this one would be your Q1, your quartile 1. Here this would be your Q2, which is your median. Okay, which is your median, and here this one will be your Q3, and this would be your max. Now let's say if you are visualizing this data and your data set also contains a outlier. So in that case, you would see an outlier over here, somewhere around this. So this you can consider as your outlier. Okay, outlier. Okay, so we have seen the measures of location. We have already seen mean, median, mode in our previous sessions, which is the measures of central tendency. We have seen min, max, the quartiles, percentile, and decile. Okay, so let us now talk about the skewness in the data. So when you start your data analysis process, you would be receiving different sets of data, and when you try to visualize the data, it is guaranteed that you won't be getting all the data always in the form of normal distribution. It can have a bimodal distribution. The data might be skewed as well. So let us first understand what is skewness, what is positive skewness, and what is negative skewness. Okay, so I'll just draw a diagram for you to understand, to have an idea about it. So we have already seen normal distribution and bimodal distribution, but let me just quickly go through around it. What is a normal distribution representation wise? So let's say this is your x and y axis, and if you see a data which is in the form of this way, this is called as the normal distribution. And similarly, bimodal distribution, you will get two modes over here. So if you visualize the data which is in the format of, let's say, this way, this is called as the bimodal distribution. Okay, in this case, in the normal distribution, the mean, median, and the mode is equal. So let us now talk about the positive skewness of data. Okay, so this is your again x-axis, and this is your y-axis. Now if you plot your data over here to understand the distribution, let's say if you have certain histogram over here, okay, so let's say this would be your data. Okay, somewhere around this way. So here if you see this one, and if you see a long tail on the right hand side, this way you say that this data, this distribution is skewed. This is positive skewed distribution of the data. Okay, here you are seeing a long tail on the right hand side. So here in between somewhere you will find your median over here. So here you, if you can see here, this actually this diagram should be, let me just, yeah, this should be this way. Okay, this way. Okay, let me draw again. I know I'm not very good in that. Okay, now I think makes sense. Okay, so here if you see this bin, this is the highest, so this would be your mode. Okay, this would be your mode. Somewhere here you would find your median, and here you can find your mean. Okay, so this is all about the positive skewness distribution. Similarly, let's say this is again a set of data wherein you will find the distribution. In this case, you saw that okay, the peak was over here and you saw a long tail on the right hand side. In this case, it would be around this way, somewhere somewhat like this. So here if you can see on the left hand side a tail, okay, and there is peak in the data on the right hand side. So this would be called as negative skew distribution. So this would be a better diagram for you to understand actually. Okay, because see here, if you see over here, this would be, you see a peak over here and then a long tail over here. Okay, so this is positive skewness, and here if you see it would be a long tail on the left hand side and then a peak over right hand side. So this is called as the negative skew distribution.